Hello friends, today we are going to start a new topic, that is gradient. In vector calculus, gradient, divergence and curl, these three topics are very important. So out of that, first we will take gradient. In gradient, most important thing is del. So what is this del? Del is also called as nabla, and this del is vector differential operator, that can be written as del is equal to I bar dabba by dabba x plus j bar dabba by dabba y plus k bar dabba by dabba z. So if this del is vector quantity and suppose scalar quantity given a phi, and if we operate this del on scalar point function phi, then we get vector quantity del phi. So how we write del phi? Del is this I bar dabba by dabba x plus j bar dabba by dabba y plus k bar dabba by dabba z, and phi is this phi of phi is function of xyz. So we can find partial derivatives of phi with respect to xyz. So del phi can be written as del phi is equal to I bar dabba phi by dabba x plus j bar dabba phi by dabba y plus k bar dabba phi by dabba z. So this del phi is called as gradient of phi, or in short del phi is called as grad phi. Now some concepts are there. Suppose u and v are any scalar point functions, then how we find del of u plus v, del of u minus v, del of u into v? Same as rules of derivative. Del of u plus v or del of u plus or minus v can be written as del u plus or minus del v. Similarly, del of u into v is equal to u into del v plus v into del u. That is product rule. Then division rule of derivative A, del of u by v is equal to u into del v minus v into del u upon v square. And suppose a is any constant and u is scalar point function, that is xyz, means u is function of xyz, then del of u au can be written as a into del u. Now in gradient, most important topic is directional derivative. For theory and some exams, this directional derivative is very important. So what is directional derivative, or how we find directional derivative? The directional derivative of scalar point function phi in the direction of vector u bar is given by del phi dot u cap, where u cap is equal to u bar upon magnitude of u bar. This u bar is directional vector. So how we find dd? In short, directional derivative is called as dd. So dd of phi can be written as del phi dot u cap, and we know that dd is maximum in the direction of del phi. So we can add here one note, that is directional derivative is maximum in the direction of del phi, and its maximum magnitude is magnitude of del phi. Now if we take one example here, example A, find the directional derivative of scalar point function phi is equal to xy square plus yz square plus zx square along at point 1 1 1 along the line 2 into x minus 2 is equal to y plus 1 is equal to z minus 1. So how we solve the problems on directional derivative? First important thing is, first write down formula dd is equal to del phi dot u cap. Now how we find del phi? Phi is given in problem, from that we have to find del phi. So del phi can be written as I bar dabba phi by dabba x plus j bar dabba phi by dabba y plus k bar dabba phi by dabba z. Now phi given a, phi is equal to xy square plus yz square plus zx square. So here phi is function of three variables x, y, z. So we have to find partial derivatives of phi with respect to x, y and z. Means simply we have to find dabba phi by dabba x, then dabba phi by dabba y and dabba phi by dabba z. Now first, if we take suppose derivative of phi with respect to x, that is dabba phi. Here phi, we will write again phi is equal to xy square plus yz square plus zx square. Now if we differentiate phi with respect to x, then we have to take y and z are constant. So what is dabba phi by dabba x? Here y is constant, derivative of x is 1, that is y square, plus yz constant, so derivative of middle term is 0, and plus z into derivative of x square is 2, so 2zx. This is dabba phi by dabba y. Similarly, we can find dabba phi by dabba y. So how we write dabba phi by dabba y? Here derivative of this xy square is 2xy. This x is constant, derivative of y square is 2y plus z square, and plus derivative of last term is 0, and similarly dabba phi by dabba z is derivative of this term is 0 plus derivative of z square is 2z, means 2yz, and plus here derivative of this term is x square. So these are three derivatives of phi with respect to x, y and z put in del phi. And therefore how we write del phi? Del phi is equal to I bar dabba phi by dabba x, means this one. Del phi is equal to I bar dabba phi by dabba x plus j bar dabba phi by dabba y plus k bar dabba phi by dabba z. Here put the values of dabba phi by dabba x, dabba phi by dabba y, dabba phi by dabba z. Then we can write del phi is equal to I bar into dabba phi by dabba x, that is y square plus 2zx plus j bar into dabba phi by dabba y 2xy plus z square, and plus k bar into dabba phi by dabba z is 2yz plus x square. Our question is find directional derivative of phi at point 111. So we have to find del phi at point 111, means this del phi in terms of x, y, z is, so here we have to put x equal to 1, y equal to 1, z equal to 1. If we put y equal to 1, z equal to 1, x equal to 1 here, so 2 plus 1 is 3 I bar, plus same here 2 plus 1 is 3 z bar, and plus same here 2 plus 1 is 3 k bar. Means all the values of x, y, z are 111. So this is the del phi at point 111, that is 3 I bar plus 3 j bar plus 3 k bar, means half problem is over here. Now our question is find the directional derivative of phi at point 111 along the line. We have to find dd along the line, that line given it 2 into x minus 2 equal to y plus 1 equal to z minus 1. Means if we divide throughout by 2 here, then we will get x minus 2 upon 1 equal to y plus 1 upon 2 equal to z minus 1 upon 2. So this is the equation of line passing through point 2 minus 1 1 having direction ratios 1 to 2. Means DRS of this line is R1 to 2. So using this DRS we can write directional vector u bar, that is from 1 write I bar plus 2j bar plus 2k bar. Means from direction ratios write down directional vector u bar. Now for directional derivative what we want unit vector of this, so I find u cap unit vector is equal to u bar upon magnitude of u bar equal to I bar plus 2j bar plus 2k bar upon its magnitude is under root of 1 plus 2 square plus 2 square. So what is this? This is 1 upon root of 9 into I bar plus 2j bar plus 2k bar, and root 9 is 3, so can be written as 1 by 3 into I bar plus 2j bar plus 2k bar. So this is the unit vector Now we have to find directional derivatives. Our formula is dd is equal to del phi dot u cap. Now what is the value of del phi at 0.111? Del phi at 0.111 is 3 I bar plus 3 j bar plus 3 k bar, and u cap is this, put here, is equal to 3 I bar plus 3 j bar plus 3 k bar dot 1 by 3 into I bar plus 2 j bar plus 2 k bar equal to 1 by 3 into 1 by 3 take outside, and how we take dot product of two vectors. These are the two vectors. This is our first vector, this is another vector. Suppose a1 I bar plus a2 j bar plus a3 k bar. This is b1 I bar plus b2 j bar plus b3 k bar. So dot product can be written as a1 b1 plus a2 b2 plus a3 b3, means product of this, that is 3 plus 6 is equal to 6 plus 6 is 12, 12 plus 3 is 15 by 3. So this is the final answer. Directional derivative of phi is equal to 15 by 3. Now we will take next example, that is next problem is same problem, and this is very simple as compared to last problem. Find the directional derivative of the function phi is equal to x square y plus xyz plus z cube at point 1 2 minus 1 along the direction 8 I bar plus 8 j bar, means directional vector is already given here, that is u bar is given. So first we have to find del phi, and phi is given a x square y plus xyz plus z cube. Now how we write del phi? Del phi is equal to I bar dabba phi by dabba x plus j bar dabba phi by dabba y plus k bar dabba phi by dabba z is equal to derivative of phi with respect to x is 2xy plus yz plus j bar into with respect to y is x square plus xz, and with respect to z is xy plus 3z square. But we have to find del phi at point 1 2 minus 1. So put x equal to 1, y equal to 2, z equal to minus 1. If you put here, then I bar into x equal to 1, y equal to 2. So 2 into 1, 2 into 2, 4. And 2 into minus 1 is minus 2, 4 minus 2. Plus j bar into x equal to 1, 1 square is 1. X equal to 1, z equal to minus 1, that is minus 1, 1 into minus 1. And plus this xy, x equal to 1, y equal to 2, that is 2, and plus 3 into 1 square, minus 1 square is 1, so is equal to 2 I bar plus 0 j bar plus here k bar, 3 plus 2 is 5 k bar. So this is del phi at point 1 2 minus 1, because our question is find dd of phi at point 1 2 minus 1 in the direction of directional vector given a u bar is equal to 8 I bar plus 8 j bar. K bar is not given, so right here 0 k bar. So what is dd? Directional derivative is equal to del phi dot u cap. This is the formula. Now del phi at point 1 2 minus 1 is put here, that is 2 I bar plus 0 j bar plus 5 k bar dot u cap is, you can write here more step, del phi dot u bar upon magnitude of u bar. Now what is u bar? U bar given a 8 I bar plus 8 j bar plus 0 k bar upon under root of 8 square is 64 plus 64 plus 0. So after solving this, 2 into 8 16 plus 0 upon 64 plus 64 is 4 plus 4 8 and 6 plus 1 28. So answer is 16 upon under root of 128. Okay, then next example is find the directional derivative of the function phi is equal to x square y z cube at point 2 1 minus 1 towards the point 1 minus 1 1. Here also we have to find first, that formula dd is equal to del phi dot u cap. So first we have to find del phi, and del phi is I bar dabba phi by dabba x. Now what is dabba phi by dabba x? Using this 2xy z cube plus j bar into dabba phi by dabba y x square z cube plus k bar into dabba phi by dabba z, that is x square y into 3z square. Our question is find del phi at point 2 and minus 1. So in any problem, first find del phi at given point, that is 2 1 minus 1, means put here x equal to 2, y equal to 1, z equal to minus 1. Minus 1 cube is minus 1, y equal to 1, x equal to 2. So 2 into minus 1, minus 2 into 2, minus 4. Plus j bar into here 2 square is 4, minus 1 cube is minus 1, that is minus 4. And plus k bar into x is equal to 2. So 2 square is 4 into 1, that is 4 into 3, 12, because minus 1 square is plus 1. So this is minus 4i bar minus 4j bar plus 12k bar. So this is the del phi at point 2 and minus 1. Now our question is we have to find directional derivative of the function phi is equal to this at point 2 and minus 1 towards the point 1 minus 1 1, means how we find here u bar. That points are, say, you have to take u bar is equal to vector pq towards the point pq, where p is equal to 2 1 minus 1 and q is 1 minus 1 1. So these are the given points, and using this we have to find directional vector u bar. So how we find position vector, that is u bar is equal to towards the point pq, means q minus p. pq, position vector pq can be written as q minus p, that is 1 minus 2 into I bar, then plus minus 1 minus 1 into j bar, and plus 1 plus 1 into k bar. So this is minus I bar minus 2j bar plus 2k bar. So this is the u bar directional vector, and therefore dd is equal to del phi dot u cap equal to del phi dot u bar upon magnitude of u bar equal to del phi is minus 4i bar minus 4j bar plus 12k bar dot u cap, that is minus I bar minus 2j bar plus 2k bar upon under root of 1 plus 4 plus 4. So 1 plus 4 plus 4 is 9, root 9 is 3, 1 by 3 into dot product of this, that is minus 4, minus 4 in minus minus plus 4, minus 4 into minus 2 is plus 8, and plus 12 into 2 is plus 24. So what is this? 8 plus 4 is 12, 12 plus 24 is 36 by 3, so answer is 12. So next problem is find the directional derivative of phi is equal to e to the power 2x into cos of yz at point 0 0 0 in the direction of tangent to the curve x is equal to a sin t, y equal to a cos t, and z is equal to at at t equal to pi by 4. So I will give you only hint here how to solve this problem. First find del phi at point 0 0 0. Means for del phi we have to find dabba phi by dabba x, dabba phi by dabba y, dabba phi by dabba z using find derivative of this, and in that derivative put xyz equal to 0 0 0. After that, how we find vector u bar here? So in which direction? In the direction of tangent given a. So how we find tangent if given equation of curve given a? For tangent we have to consider position vector r bar is equal to xi bar plus yj bar plus zk bar. So if using r bar we can find tangent t bar is equal to, and tangent t bar denote here vector u bar, that is equal to dr bar by dt. Take dx by dt into I bar plus dy by dt into z bar and plus dz by dt into k bar. Now xyz is given in problem, so find dx by dt, dy by dt, dz by dt in terms of t, and in finally put t equal to pi by 4, then we get vector u bar equal to something. Okay, and after that from u bar find u cap, and then write formula dd is equal to del phi dot u cap and solve this. Okay, thank you.